So, what I have here, guys, is two different games of chance shown below can be played at a charity fundraiser. In each game, the player spins an arrow on a wheel and wins the amount shown in the sector that the arrow stops on. Each game is fair in that the arrow is just like to stop on one sector as any other sector on the wheel. John plays game A 4 times and tells us he wins a total of €8. How many different ways could he have done this? Okay, so he has to win €8. Okay, so you have to make up a couple of combinations that add up to €8. Okay, so lads, you can rule out the following scores. You can rule out 6 because 6 plus anything else on the board will not give you 8. So an example would be I could go 0, 0, 5, 3. I could say 0, 0, 3, 5. Yeah. And then what about the other ones then? Let's start off. Let's move this one across one at a time. Okay. So 0, 0, 5, 0, 3. Move the 5 across. 5, 0, 0, 3. What else do we not have here?
3,
Sorry.
0, 5, 3, 0.
0, 5, 3, 0. Anything else?
5, 3, 0, 0.
5, 3, 0, 0.
5, 3, 0, 0, 3, 0.
5, 0, 3, 0. And likewise 3, 0, 5, 0. Now, I have a backup to this, alright? Now,
I have a question like this actually.
yes.
I don't understand. The other way, the first one, you have.
There's 12 in total, okay? So what I gotta do is I got to figure out where the other ones are coming from, okay? So, do I have 3, 5 in the middle? 0, 3, 5? 0. So guys, 3, 5, 0, 0. Did I not do that one yet? Nope. 0, 3, 0, 5. Yeah.
3, 0, 0, 5.
There you go. Right. Now, that is your 12 different combinations. Okay. Now, what I'm going to bring your attention to is imagine that each one of these is a distinctly different number. As an example, would be 1, 2, 3, and 5. Okay. 1, 2, 3, and 5. In a case like this, you have 4 factorial ways of distributing them. Does everybody understand that? So I could have 1, 2, 3, 5, 1, 2, 5, 3, 1, 5, 2, 3, or 1, 5, 3, 2. Is everybody alright with that much? That 4 go in the first box, 3 in the second, 2 in the third, 1 in the fourth. Now, what happens is, that's great, provided no objects are the same. However, when you have objects that are the same, as an example, the 2 zeros are considered to be identical. You stick with your 4 factorial, and then you divide by the number of objects that are the same factorial. So there's 2 zeros, which make that 2 factorial. And the answer to this is 12, that we verified with all 12 combinations, right? Now, if I was to, this has nothing to do with the question we're being asked here at the moment, right? So, if I ask you to make how many combinations of the word loop is there? Combinations of the word loop would be the same thing. 4 factorial because there's 4 letters. 2 of them are distinctly the same. 2 factorial. Now, if I went one step further, right, and I gave you this combination here, A, B, sorry, I'll just go online. Not necessarily words, but codes. A, B, B, C, 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 D, E, F, G. How many letters do I have? 10. 10 factorial for a start. Now, it's not as big as 10 factorial. Can anybody tell me why it's not going to be as big as 10 factorial? Because the repetitive B's and the repetitive C's. Now, treat it like last time. 2 zeros, 2 B's means 2 factorial. And then 3 C's on the bottom. 3 factorial. And then you'll get your number of combinations in total. Is that alright? So it's always your number of letters factorial, or your number of different outcomes factorial, divided by the number of the number of the ones that are the same. So in this case 2 factorial, however in this case a 2 factorial followed by a 3 factorial. No. Has to be done this way, okay? Now, next one, guys. To spin the arrow once, players pay 3 quid. Which of the games would you expect to be more successful raising funds for the charity? Give a reason for your answer. It's the one that we make less money on. So,
Yeah, I can pause for a second.
yeah. What to do is you want somebody to lose, and the charity is the game itself. Therefore, the player, if he wins a lot, he takes money away from the charity. So you're looking for the player to make as least money as possible. Simon. Okay. So what we have here, guys, is this. Okay. So what I'm going to say is we're going to make a little table. I'll use the question above for the table of scenario 1, so to speak. Alright. So here's what we're going to do. In game A, guys, how many outcomes in game A? 5. Okay. So 5 outcomes. Okay. Now you're doing what's called the expected value. Don't know if you've seen the expected value in a while. So what you have is your outcome, which is our outcomes are 0, 3, 5, and 6. Okay, although there's 5 different sectors, there's only 4 outcomes because 2 of the sectors are the same outcome. Now the probability of sector 1 happening, or sector 0, 2 and 5, sector 3, 1 and 5, sector 5, 1 and 5, sector 6, 1 and 5. Now the expected value is the sum of all of your outcomes multiplied by their probabilities. So the first one's going to be 0, second one, 3 and 5, next one, 1 after that, 6 and 5, and what we're going to get here is going to be 9 and 5, 14 over 5. What's 14 over 5? When you 14 over 5 is when you add them all together. So 6 plus 5, 11, 14 over 5. What's 14 over 5 in euro? Anybody tell me? €2.80. On average, I'm going to win €2.80. I won't do anything else just yet. I'm going to do game B now, okay? So game B being down here. Game B is it 6 distinct outcomes, or is anything repeated? 6 distinct, okay? So 3, 4, 5, and 6, okay? Then I'm just going to make a chart like this every time. So your outcomes are, what's the smallest? 0, 1, 2, 3, 4, and 5. Your probability of 0 happening? 2 or 1. They're all 1 and 6, are they? Okay. Now that you're done with that, you're going to get your expected outcome. So you're going to multiply them all. So you're going to get 0, 1 and 6, 2 and 6, 3 and 6, 4 and 6, 5 and 6. To get your expected outcome, you add them all together. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 10 is, 6 plus 4 is 10. 15 over 6, and what's 15 over 6? €2.50. Now, so from what we see here is that in game A, you win €2.80 on average. Okay? However, you pay €3 to play the game, don't you? €3 minus 2.80, you pay more than you win. So you're down 20 cents. This means that game A raises 20 cents on average. Likewise, game B, 50 cents on average. Okay? And that's that question answered. Now, last part. Mary wins game B 6 times. Find the probability that the arrow stops in the number 4 sector exactly twice. This is Bernoulli's. Okay? Now, let me explain what happens here, right? So she wins game B 6 times, okay? So first of all, we're going to write down PQ. What are the letters again? P. Oh, there it is. P, Q, and R, and N. Now, if you fill this out successfully, you're going to get it right, no matter what. Okay? And the formula is for Bernoulli's is NCR. Can anybody explain what does the NCR take into account? The NCR takes into account the combinations of how it could go down. Okay? And the other one is probability of failure, right? So what's your probability of success? A success is that you you get the number 4 in game B. Number 4 in game B, anybody? 1 in 6. Your probability of success is 1 in 6. Your probability of failure? Because the probability of you not getting a 4 is 5 in 6. What is your R value? Your R value is your number of successes. You want 2 successes in 6 games. Okay? What's your N value? How many games have you played? It's 6, okay? Now let me run you over this. NC2 is the number of combinations, different combinations for the game here, okay? How many ways can, for example, if I got a, let's call it this, okay? 4, no 4, 4, no 4, no 4, no 4. That is one combination. Another combination could be 4, 4, no 4, no 4, no 4, no 4. Have we got that? Now, that's taken care of, what's your probability of success? And how many times are you going to be successful? Twice. Your probability of failure? And the number of times you're going to fail? 6 minus 2 is 4. And then put that into the calculator. 0.201. Okay. 7. What we have here is table 1 gives below the details of males and females aged 15 and over at work, unemployed or not in the labour force for each year from 2004 to 2013. Okay, so what it does is, okay, it breaks each one up. So an example would be you, seems to be a decimal point as well. Gives details of the number of males and females aged 15 and over at work, unemployed. So what I'm finding out here at the start now, as a first time looker of this question, I'm finding that the 1784.8 odds, surely you have a person or you don't have a person. Okay, so maybe it's, sorry? Oh, it's in thousands. Okay, it says it there actually. So that would be the first thing I'm looking for, and immediately after the guide stage, you're looking for additional information that might help you with what that could mean. So this means multiply them all by 1,000, and that will give you the real number as opposed to the weird decimal number that doesn't really work as a human being, because you can't have 0.8 of a human being unless it's an average. Okay, and it states that it's not an average. So back to this question in hand. This would mean that you have 1,784,800 people at work in total. Of them, 738,900 of them are female, while 1,045,900 of them are male. That's what this means. Then you go to the middle section, which has 79,600 people, males unemployed, 31,600 females unemployed, and a total of 111,200 people unemployed. And then you just have people who aren't in the labour force. Okay, so let's get to answering this question. Suggest 2 categories of people aged 15 years and over who might not be in the labour force. This is just common sense. The elderly being one, and what would be the other one? Sorry? Elderly and homemakers, right? Homemakers would be a parent that decides to stay at home to look after the house or look after the kids, okay? So you have elderly and homemakers. Students, yeah. I'd also say you could have people who are unfortunately occurred an illness or a sickness that stops them from working. Okay?
Literally anything to really work.
Yeah.
Well, that chance to that though.
Okay. Find the median and interquartile range of the total persons at work over the period. Okay, so we're going to work specifically on the people at work. And what year does it give us? Over the period? The whole lot. Okay. So, this is an unusual one. Okay, we're going to order the list of people at work. Okay, so we're going to order this list here, the totals. Now it says persons. Persons, male and female category ain't relevant. Okay, so what we're going to do is order it in according to size. So we're going to have 1773 We're going to have 1784.8, followed by 1803.4, followed by 1813.4. Then we're going to have 1828.6. We're going to have 1828. Oh, sorry, I already wrote that one down. 1867. Yeah. Just keep looking at that list I have there. 67, and then we have 1903.3, 1954.9, and then 2049.6, followed by 2060.4. Now guys, what we have here is, how many different objects do we have? 10, isn't that right?
10.
So you have 10 of them here. Now what you got to do is you got to figure out what is the median first of all. Now if you have 10 people, what can you tell me about the middle? The middle there's a middle 2 because it's an even number. If there are 4 people, there's a middle 2. This extends to 10 people where there's also a middle 2. The middle 2 is you get your number, you divide it by 2. If you get a whole number like 5, you have to round it up. So what happens when you round it up? So it's the 5th and 6th person. Oh sorry, you don't round up, as in 10 divided by 2 gets you 5. When you get a whole number, it means that you got to do that one and the one above it. So what's the 5th and 6th? 1, 2, 3, 4, 5, this one here, and this one here. To get the median, add them together and divide by 2. So 1828.6 plus 1867, all divided by 2. Your answer will be 1847.8. That's your median done. Now we're on the interquartile range, okay? Now to do the interquartile range, you get your 10 people and you divide it by 4, because that's what interquartile range means, quarter, okay? So the interquartile range, does it say interquartile range? Yeah. So the interquartile range is the first quarter minus the third quarter. So you're going to get Q3 minus Q1 is how you do this. Now, to get Q1, you divide 10 by 4 and you get 2.5. That always rounds upwards. It doesn't matter if it's 2.25, you're going up. It means the third answer. What's the third answer? Okay, so 1803.4. Now, multiply your 2.5 by 3 to get the third quarter, or 10 multiplied by 3 quarters. 7.5 rounds up to 8. 10, 9, 8. 1954.9. Okay, take one away from the other, and you get an interquartile range of 151.5. Please remember that is the same thing as 151,500, because you're multiplying by the hundreds of thousands. In the same way, the last question was 1,847,800, because it specifies that, as we said right here. Okay, it's hundreds of thousands. Alright guys, moving on. Part C. Oh sorry, part 3. Is that in the right place, part 3? Oh no, sorry, that's C part 3, excuse me. That's after part C, excuse me. So, just go down here for a second. Now, C part 3, down here. Okay guys, the following data was obtained from table 1. The percentages of persons aged 15 years and over are work, unemployed, or not in the labour force for the year 2006 are given below. So what they did here, guys, see this 57.9? Yeah. So you go back here and you go, how many people are at work? So we're talking about the totals, aren't we? Is it people or sex specific? People. So see this here, persons. So we're talking about persons, okay? So what I need to do here is I need the following. I need to find the 2006. I want the people who are. I want the total people at work. I want the total people unemployed. I want the total people not in the labour force. and I need to know the grand total of the population. So let me show you what I'm going to take out of this. Okay, so I'm going to take out this is I'm going to circle it first. 2006, right? I want this part here. I want, oh sorry, I sort of rubbed out part of it there. So I want this part here. I want this part here. I want this part here, and I want the total. Okay, and then on the other one, which is 2011, we're going to do that in a second. I want this one here, this one here, this one here, this one here. Okay, and once I've settled on that, do next is just capture this part here and then bring it over. So you have everything you need circles. Okay, so cut that, bring it over. Okay, so now we have the relevant information. Okay, so let's examine the 57.9. I reckon he divided out, see the 1954? Ever see the 1954?
Yeah.
0.9? I reckon he divided that by the grand total of 3376.1. And what's that, 57.9? So basically, you're at work divided by your total, you're unemployed divided by your total, and not in the labour force divided by your total. Get you each percentage individually. Okay, so what I'm going to do is for 2011, I'm going to do 1813.4, and then I'm going to divide that by my 3599.1 multiplied by 100. What do we get for that? 50.4?
Yeah.
Okay, the next one I'm going to do in red is going to be my 364.1 divided by my 3599.1, and what we get there is 10.1%. And finally, not in the labour force, is our do it in green, our 1421.6 divided by our 3599.1 multiplied by 100 again, and we get 39.5. Okay, give your answer to one decimal place, done. Okay, part 2. A census in 2006 showed that there were 864,449 persons in the population aged under 15 years of age. The corresponding number in 2011 census was 9,709,590. Assuming none of these persons are in the labour force, complete the following table below to give the percentages of the total population at work, unemployed, not in the labour force for the year 2011. Do you remember in the last question? I actually think I'll bring back these numbers. Do you remember I had these numbers here a second ago? Now, what I'm going to do, what I'm going to do here is I'm going to modify this. Any idea how I'm going to modify that? I have to add that onto my 3599. See that? Because that's out of the working population, the people in the the people in the statistics we had. We left out a full 979,590 people. Divide that by 1,000 for a start. What happens when you divide that by 1,000? Shh, lads. Divided by 1,000, and we get our 979.59. Going to add it on to the 3599.1. And what we have here, four 4,578.69. Okay, so 4,578.69. So 4,578.69. Can somebody do the first one for me? And I'll just write down the other ones now. 578.69. 4,578.69. So we put in the modification of putting the extra under 15s in to make a percentage of the total population. Connor.
But you'd have to add them to the...
So guys, what do we have here for the first one?
39.6.
39.6 for people at work.
Here
So what we have here is our 39.6. Now, people, is this 8%? Can anybody tell me? This part here?
Yeah.
What? Now, that's because people under 15 years of age cannot be considered unemployed. So they can't be considered unemployed because they're not employable. Okay? So that's that one done. Now, as Connor stated, we have to modify this not in the labour force, because people under 15 are considered not to be in the labour force, alright? So what was that last number we had? Our 1421.6, and we had to add that onto our, 979.59. Can somebody give me the total for that? 2401.19, and then I want you to divide it by the 4578.69, multiply it by 100. I'm hoping that you'll get 52.4%. Now, part 3, a commentator says that the changes reflected in the data from 2006 to 2011 make it more difficult to balance the government's income and expenditure. Do you agree with this statement? Give 2 reasons based on your answers. Okay, so guys, what we have here is 2 reasons. You have more people at work. Less people, more people who are unemployed. This means more social welfare, which means more government expenses. Less people actually working. People who work get taxed. Because they're not getting taxed, that's less income coming into the government, hence less money to spend. Okay? So that's why you might have some cutbacks coming in and whatever else when you see figures like that. Now, Liam and Neve are analysing the number of males and number of females at work over the period of 2014 to 2013. Liam draws the following chart using table 1. So you can see that the number of males at work went here, and then the number of males took a bigger drop than the number of females. That's quite obvious from the trend graph there, okay? Now, using the same, I think then Neve used the same data and calculates the number of females at work as a percentage of the number of persons at work. So what Neve is doing is Neve is dividing the number of women divided by the total amount of people at work. So what she's saying is that as a percentage of the population, you can see that women are a higher percentage of the working population. They're getting to a higher stage. They started off at 40%, now they're at maybe, let's call it 46%. That doesn't mean there's more women working. It just means that there's a higher percentage of women working as a percentage of the total population. Connor? And that means that at the end there's 46% of the workforce are women, 54% are male. Likewise, if we call that 41 at the start, that means 41% women, 59% male. Okay, what is the actual question? Okay guys, so what the question is having examined both charts, the commentator says females were affected just as much as males by the downturn in employment. Do you agree with this statement? Give a reason for your conclusion. I would say as a percentage of the population, there was 41% women. 41% women. 4% of the working population were women. Would everybody agree with that?
Yeah.
While in 2011, 46% of the working population are women. Now, there's another way of looking at that as well. The other way of looking at it is that 2006 is what is the question referring from 2014? So, comment says downturn in employment. Okay, downturn in employment. So let's look at the maximum. The maximum for men occurred here. Let's call it roughly 190. Let's call the rock bottom is 1,000. So what is 190 as a fraction of 1,000? Anybody tell me? 190 as a fraction of 1,000 is 19% decrease. Okay. Let's do the same for women. Let's call this number, let's call it 890 as an estimate. Let's call the minimum amount is? No. We're talking about the downturn. So the bus. So what I'm doing as a fair test, I'm taking the maximum of both of them after this point here, and then I'm taking the minimum, which is this one here, and then I'm going to calculate what percentage of the workforce lost their job. Okay, just as a rough estimate. Okay.
Is that not is the rock bottom not 550?
Which one here?
For the males now.
This one?
Yeah.
Is it 950?
It's below 1,000, I think that's
Somebody told me thousands. Sorry, it's 950. We'll go again. Okay. Sorry, I actually did that wrong anyway. Sorry guys, it's your percentage at the start was 1190 anyway. Excuse me. That's how many people work it. Rock bottom is 950. Take them away. So what is your change? What's 1190 take away 950? So how many people lost their job roughly? Come on guys, 1190 minus 950?
240.
240 over 1190 multiplied by 100. Give me a percentage of people who lost their job from the peak down to the bottom.
20.
Sorry?
20.7.
20.17%, alright? And then I'm going to do the same thing for women. Over the 890,000 I suspect are working, okay? What's the rock bottom here? What are we going to call that?
760.
No. 820, okay? 820 is 70 people lost their job, technically speaking. 70 over 890 multiplied by 100. Anybody? 7 point? Now look guys, that's fairly evident that the men are significantly more affected than the women in the downturn. What can you attribute that to? Remember the construction industry? A lot of builders, male orientated job, building industry went downhill. That might explain your 20 dropping to your 7. There's lots of different ways to prove that the men are more affected than the women using different statistics. So just have one and have a logic to what you're doing and explain what you're doing. So I'd explain the test that I'm taking the highest in the region above 2006, and I'm bringing it back to the language of the question. I'm saying but a downturn in employment. The downturn in employment happened after a certain point on the scale. That's why I ignored all the figures pre-2007, let's say. Because that wasn't a downturn, that was on the way up. Okay? Which, if any, of the two charts do you find more useful in reaching the conclusion above? Okay, the reason being is, I'm going to make this very simple, right? This chart says that 46% of your population is women that are working. This is saying 41%. Now, imagine an example. I have 2 million people working. It doesn't tell me how many people are working, it just tells me what fraction they are. 41% of the 2 million would be women, 59% of the 2 million would be male. What happened, for instance, is, imagine this was just drastically cut. Like, imagine the worst thing ever. 2,000 people are left working, okay? You go back to this stat, and it goes, oh, out of the 2,000 working, 46% are women. It tells you nothing about how many people are in employment altogether. So, using this chart for that question is really tough. However, if I go to the chart above, this chart tells me the total men and women working. So it was much easier to see how many was the maximum maximum population of men working at the boom time, and what was the minimum. So that is why the trend graph worked much more effectively than the bar chart. Okay. Covered that there above. Use the data in table 1 for the years 2012 and 2013 only to predict the percentage of persons aged 15 years or over who will be at work in 2014. A prediction. Okay, this is interesting. So add the prediction of persons who will be at work. Okay, so we got to go back to the very beginning, and it says use 2012 and 2013. So we're going to go. I actually have the table there, don't I? I can use it there. So 1 second. Okay, I use this table here. Now, that's unfortunately that's copied and pasted, so I used the original table. Now, it says use the 2012, 2013 data, right? And number of people at work. This one here, this one here. Okay, and this here and this here. So I'm just going to snapshot this again, and I'm going to bring it back.
So you did that male unemployed.
Oh, they do male unemployed. That was really smart of me. Okay. Okay, that didn't affect it at all. Sorry, so go back again. I did male unemployed. I'm looking for total at work, isn't it? This one here? This one here. Alright, now I'll just do this here. I'm going to do that as a percentage. Okay? So I'm going to go 11773.4 divided by 3590.0. Okay, multiply by 100. Can anybody tell me what that is? The number of people at work as a product of the total people in the census. 49%. Okay, and can somebody else do the same thing here for the red one? I want to see what was the percentage turn down. 1803.4 and then over 3586.2 over 100 is 50.28. Okay, so I'm going to say that your employment is up by how much? It's grand, just go for it. Just take away the two percentages.
Yeah.
Go for it, it doesn't matter.
Sorry, yeah. I did it with the decimal.
0.89, is it?
Yeah.
So employment's up 0.89%. Okay. So I'm going to assume a similar trend for next year. That's what economics guys do. They take a prediction and then they say, look, let's hope it continues the same next year. So let's add on another. So we're expecting another 0.89 added on top of that.
51.17.
51 point. Okay. And does it just want the percentage or the total number of people? That question. So it's 51.17. Just give me a second. Yeah, I think you might want to make a prediction for the total number of people as well. I think that might be the next thing. Oh, the percentage, grant. 51.17%. Follows a similar trend. Okay? Yeah, they have 51.19, so